Hello and welcome back. So last time we looked at the smelting build and I basically placed it down and then had some circuitry to fiddle about with. That's no good, that doesn't seem to have any power. Okay, find one that does. Oh goodness me. Right, let's run over there and fix that. Get my running legs on. No, I must have them on already. Okay, so this is starting to turn into the high volume materials bus. I've put down a build for iron smelting, for steel smelting, and for copper smelting. So those are the three big smelters. Well, they are the three smelters. I found a couple of bugs with the design. So, what's going on here? Let's have a look. Oh yeah, it's my fault. So, found a couple of bugs with the design. First of all, this outlet here wasn't originally signaled. So the train would have left the station, got to here and stopped potentially, and blocked the next train coming in, which is very sad. So I had to add in a signal, and signals can't go on curved tracks, so I had to lengthen out the track by one tile here, which meant moving all this around by one tile, well, one pair of tiles, and because rail tracks are awkward, it was awkward. So I'm glad I did that off camera. Other things I did. So the filter inserters here, you can't really see it for all the cabling, but that is periodically flashing with an iron plate signal. This is a clock. It counts, these two together make a clock. T+1 is the output, input is T. This says if T is less than 75, output the input count, T to T. So whenever T hits 75 as the input, the output is 0T, that resets the clock. Then here, whenever T is equal to 0, output an iron plate. That then goes across this green wire, and that green wire controls this filter. So every 75 ticks, the machines will empty of plate. It's worth doing for smelters because they have a low production rate per machine. It's not worth doing for some of the other builds, like the green circuits, for example, because they are just constantly churning out stuff. So turning off the inserters doesn't help. Okay, the other bit of magic. We have a decider combinator. Whenever there are fewer than 32,000 plates, output a 1. That is the set signal. This is a set reset latch. And that is adding up to the total amount of stuff in these chests. 32K is enough to fill a single train. The reset is whenever the output is greater than or equal to 64K, that would mean both these chests are full. Now, there's a bit of a buffer on these, so I'm only filling them up 4 rows. The 5th partial row I'm leaving empty. It's not needed to fill a train, and basically who cares. So then this goes through here. Whenever the number of sets is greater than the number of resets, output a set. And turn this switch on whenever sets are greater than 0. So this is going to then supply power to this outer circuit. And if we look on the map view, you can see there's power that comes down here. This power services the drone ports and the train loading and unloading. This then is a bit of copper cable that breaks up the electric network on the switch. Then the whole of the outside here is powered from that set reset latch. So whenever there are 64K plates waiting to be picked up, this module will turn itself off. The drones will carry on being live, so they'll carry on emptying and filling chests. The trains will still be able to empty and fill because their inserters are still live, but this module will be turned off. That means there are no machines sat idle. They're either on working at full speed or they are off. That's the idea. And then the one last bit of magic here to make the set reset latch work is that the output is wired to the input using a red wire. And that's what latches it. So whenever you have a one set output, you have a one set input. So that latches it into on. If you then fire a reset, that's one reset to one looped back set. That would be one set and one reset. Set is not bigger than reset, so that would unset S, turning the latch off. Okay, so that's the idea. And we have pretty much this build cloned for copper and for steel. Okay, so what next? Well, now that we have potentially copper and iron plates, the obvious thing to do is to make green circuits. And I'd like to get this going as early as possible. I need the green circuits for, well, everything really. I am tempted to turn off all my green circuit making at the main base and start bussing them in. But before we do that, we need a green circuit build. My experience is that green circuit builds are the worst build in-game. They just chew through materials. You really need to make the coils on site, otherwise you spend your entire life moving copper coil around. But if you make the coil on site, it's because one plate becomes two coils. That's before prop mods. After prop mods, one coil becomes 2.8. Sorry, one plate becomes 2.8 coils. So that's nearly 3. So it's a massive space expansion. So you want to make these as close as possible to the green circuits. Ideally directly insert them. The problem with that then is you can't really fit 12 beacons around very easily. You have to have at least 2 stack inserters emptying the coil machines, otherwise they back up. And it isn't a perfect 1-to-1 ratio, so one green circuit maker consumes more than one copper coil maker. And I thought I would illustrate that here. Okay, so max rate calculator. So here is our pair. This is a green circuit and copper coil. I've stuck prop mods in. So this has a net number of minus 0.71 machines. So we are 7% under supplying the green circuit build. That means that the items per second, items per minute, let's go for that. So this is without speed beacons, but the green circuit build would be producing 84,000 green circuits a minute. However, because it's not being fed a full complement of copper coils, it would be doing 93% of that. So what is that? About 78 instead of 84. And that really adds up. So what you need to do is work out how many machines you need to pair up. So we could put in an extra coil machine, and now we have nearly a full machine extra, right? So that's 0.929. That is coincidentally matching up with our 0.71 from earlier, because maths. What we want is to get this number down to 0. So if we have 2 greens and 3 coils, we are 0.857 over. That's 4 and 5, 0.714. You can see where I'm going with this. So let's do that. That's 0.15. Carry on. If we go up to there, we're still not making it. Right, if we do this entire stack, this sums out at 0. So we have 1, 2, 3, 4, 5, 6, 7. We have 14 green circuit machines and 15 coil machines when they're running at the same speed as one another. That is our ratio. We need 1 extra coil machine for every 14 coil machines. And if you can feed this extra bit of coil into all these green machines, then they will run at full speed. You gain an extra 7% performance. So how do you do this? Well, the obvious thing to do would be to design this with bots. And there are all sorts of things I tried. So I tried this sort of thing and failed, and so on and so on. And I think I've come up with a build which doesn't suck. So let's head over here. We're going to grab some stack inserters, a stack of machines. I have prop mods. Let's get some speed mods and beacons. Okay, great. Don't need quite that many beacons. Let's drop off one stack so I've got an empty stack in my inventory. So ideally I would like a 12 beacon build. And let's do the compressed 12 beacon. All right, so that would be our ideal. And we would take one of these, put it in there. We would take one of these, put it in there. Sorry, go back to the blueprint. Okay, and we would make coils with one and circuits with the other. Okay, so great. Except we are then moving all of our copper cables by hand. Right, all these copper cables have to be flown about by bots. So nearly three copper cables for every iron plate that's coming in, which is just a massive increase in the drone traffic. And I can't see that ending well. So an improvement on this would be some kind of direct insert. And this is closer to the build I have come up with. So we would direct insert from the coil to the circuit machine. Now, technically we only need 2 inserters to empty the coil machine. So we can then feed the coil machine with plates. We want to feed it from low down because that's closer to the train. This is a lot of material. So that's going to be taking a stack of plates. This flashing is annoying me. Is that? Yeah. Great. Okay. So let's just check that's not anywhere important. Ooh, that is somewhere important. Where is that? Ooh, ore trains. Right, I will have to go and fix that later. I'm not going to fix it right now because we're recording. I will definitely have to go back and figure out what trains those are. In fact, can I deal with this with artillery? It's a bit of a wonder this has never happened before. No. Okay, well, they will chew through those trains. I'll have to rebuild them. Okay, so we can move this in further. There we are. Now, that is not nice because this machine lines up perfectly with this machine. So we're not getting the full benefit of the beacons. So the thing to do is rip those up, and we will place this down carefully so as to not align. So we've centered that on that inserter. Okay. And can't fit an extra one that side. Now, you'll see why I've done this in a second. So there's a gap here. Now that's fine. This is still hit by 4 beacons at the bottom. It will be hit by 4 at the top. But if you look, this has a single tile overlap this side. this has a single tile overlap this side, so we have a possibility of this thing tiling. Right, rip out the top row and put them back in their new shiny configuration. There we go. Right, the eagle-eyed among you will know that this is an incomplete build. So this needs plates, and we may as well get them from as low down as possible, because this is our thing, right? If we can do things low, which means that they don't have to travel as far from the train, we do that. Then we need to take in extra copper coil. So let's set a request here to a stack of coil. And then we can produce some output. Let's put it there. So you don't produce very many of these green circuits for, and let's set that to 2 stacks just so we've got a bit of a chance. Okay, you don't produce very many green circuits for quite a lot of incoming iron and copper, so I'm quite happy to have this higher up to be emptied. Right, so that's our module basically. Now, let's ask max rate. Okay, so this is producing 1.1k green circuits, ideally. That's really bugging me. Which is really cool, over 1k per machine. We have a deficit. Now the way to fix the deficit is to have a single machine, which is taking in plate, putting out coil. Now we need to be really definite about capping these. Otherwise they will just turn the world into coil. There we are. Then we can beacon this up. Okay. So that is our combined build. And let's put a beacon there. Right, now let's run max rate calculator over to make sure that we are, yep, so we have 0.929 extra coil machines. So then we can start adding this build to the left and the mirror image of it to the right, and start building it out until everything starts to balance out. Okay. Where is this happening? Did they do a good enough job of killing the trains? No, they didn't. So they left things half dead. Wonderful. Okay. So anyway, this is basically our build. We then need the mirror image of this side. I wish there was a mirror image blueprinting tool. Seriously, why haven't you done this yet, game? I mean, I know the technical reason, I'm just not very impressed, to be honest. Okay, so we want to have our coil machine there. It's going to have an input from the middle. Then it's going to have 2 outputs, and there'll be a third one from a box. And this is the box which requests the extra coils. Then we have a green machine. Give it beacons. It is going to sorry, I've mucked this up. This is ridiculous. Right, I can't put it down there, so I've got to put it up there by the side of the power. That's better. And cap that to 2 stacks. Okay, that's better. So that would be there. This is our power, and then I'll do something with cables over here, I guess. Right, let's fill in here, and we have lined things up incorrectly again. We need a gap somewhere. I think the place to put the gap is here, so that it is centered again. Yeah. So that it is centered on those inserters. That's better. Okay, so is there anything we're missing here? Oh yeah, we need some, we need an input for this, which we can't do because the gap is in the wrong place. It's because the build isn't totally symmetric, because this thing, I'm wondering if we can maybe introduce one extra gap around the blue maker, sorry, around the coil maker in the middle to line everything up. Is that a good idea? Or maybe I can shuffle the whole row 1 to the right. Okay. Let's take this. We're going to take the whole middle row. Now if we shuffle it 1 to the right, then this beacon because really what I want is the gap to be here, not here, but that means moving. If I move this, sorry to be doing all this thinking out loud. Right, if I move that there, this still hits the coil machine. Okay. Go away. Okay. Then we have 1, 2, 3, 4 hitting this. However, we can then move these 2 over. Okay, so this is 1, 2, 3, 4. So it's being hit by all these. 1, 2, 3. The problem is this one doesn't get the full 4 beacons that way. This is frustrating. Can I move this one? So this beacon doesn't touch that, so maybe I can move this beacon 1 to the right also. And then reinstate the beacon back at the bottom. Okay, so this now has 1, 2, 3. I can't see how to do this. It's because of this machine in the middle. obviously doing something a bit silly because this machine, as far as I can tell, gets 4 beacons. Ah, this machine doesn't. Because I could move that one, yeah. Okay guys, well I'm not quite sure how to finagle this. It might just be that this machine and this machine has slightly fewer beacons, which should be fine because we have too much cable being made anyway. But it's not ideal. Let's try this. Okay. So if we then grab that and put it down there. That's it. So this the flashing lights are annoying me. We need some power there, power there, and then there and there to link it. There we are. Okay. And to get rid of the remaining things, let's put down a drone port. There you are, that's got rid of all the blinking. Okay, so this, 1, 2, 3, this doesn't have 4 beacons. Grumble. It needs those 4 plus these ones to get it up to a full 10. Otherwise it's just 8 beacons. Alright, let's count this out and see what max rate says. So we still have net extra on coil because of this extra coil machine in the middle. And the issue is we need to get this right. That's our iron. Sorry, that's our coil. That's our top-up coil. This is our iron plate. Right, what would happen if this doubled as iron plate and coil? I don't like the idea of that. I can see this starving of iron because it's trying to grab iron from here and picks up coil instead. Well, let's carry on with this build and see how bad it gets. Okay. Okay, so we had the build to the left. Let's do the build to the right. And get rid of that electric pole. That's not needed. Okay, and that's still a net win. To the left. I need some more beacons. Have I really used up all the beacons? Yeah, I have. Goodness me, they go quick. Okay, and another build to the right, and we run into the rail track. So grab the whole thing, move it down to here where we have a bit more space, not a lot more, but a bit more. Right, the build to the right goes there. Okay, we're now not producing enough, and we are only 1, 2, 3, 4, 5, 6. So because of the beaconing being all wrong, rather than getting 2, 4, 6, 8, 10, 12, 14, we're only getting 6, which is pretty awful. So back to the drawing board. I need to go and resurrect those trains because my research will be going through the floor because the resources are not being brought in. We will have another think about how this could be designed. Try and get the full 10 beacons around each paired build. It may involve putting in a bit more space somewhere. I don't know. Alright, well thanks very much for watching. Sorry we didn't get something completed today. Perhaps we will next time. Alright, bye-bye.